All right, let's take a look at today's lesson. So what we're going to be doing is we're going to be learning some more identities. These are the addition subtraction identities. And I have a little story that goes with them that helps me remember. I hope it'll help you remember. These are a little bit more complicated to remember than the ones that we've done previously. There's a little bit more going on. Actually, one of my professors said this story, and I thought, oh, that's great. I'm going to remember that. So I didn't make this story up. It came from someone else, but it's great. Okay. So what we do is we're going to give sine and cosine different personalities. Okay, so sine is the nice trig function. Sine is very nice and helpful. Sine is nice and helpful, likes to share. So if you ask sine to add, sine's going to add. And if you ask sine to subtract, sine is going to subtract. Sine is very nice. Also, sine likes to share. Notice how sine is with cosine here. Now, sine does come first, sine of the first angle, cosine of the second one, and then they share. Sine shares with cosine. Sine is very nice. Then cosine s, sine t. Cosine, on the other hand, is not so nice. Cosine's not so nice. If you ask cosine to add, cosine's going to subtract. And if you ask cosine to subtract, cosine's going to add. Not very nice, is it? Also, very selfish, doesn't want to share and wants to always come first. Notice how its cosine is first. Cosine s, cosine, no sharing. Cosine is not going to share with sine, and cosine has to come first. So that's just not very nice, is it? So cosine doesn't share and has to come first. So those personalities actually strangely carry over to other kinds of formulas that we'll be looking at later. But if you can just kind of remember, sine is the really nice trig function and cosine is the not so nice trig function. I don't really have a formula or for tangent, some kind of a personality. Tangents, addition and subtraction formulas just have tangent in them. If you'll notice, so if we're going to do tangent s plus t, angle s plus angle t, we just do that in the numerator, tangent s plus tangent t. Then in the denominator, it's always 1. And since we added in the numerator, we're going to subtract in the denominator. It's 1 minus the product of tangent s, tangent t. And the same is likewise with the subtraction. So we've got tangent s minus t. We've got tangent s minus tangent t. It just carries over to the numerator. And then we have 1. So notice this is a subtraction that matches this. The numerator matches the sign of the what we're doing. And the denominator is always opposite. So it's 1 plus tangent s times tangent t. Now, you can get away without remembering the tangent formula if you wanted to. What you could do is you could literally take sine, so we could put this in the numerator, and then we could divide by the cosine. We could do that. We could, instead of doing this, tangent s plus t, we could do quotient rule and turn tangent s plus t into sine s plus t over cosine s plus t. It's possible, you can do that, and you're going to get the same answer regardless of which way you do it. It's just really what makes more sense to you. I just wanted you to know that you had that option. That's an option for you. All right, are we okay so far on the formulas? What I'm going to do is I'm going to show you several different ways that we use the formulas. So let's navigate over here to numbers 1 and 2, or excuse me, 1a and b. And I'm going to write formulas, steps, because I love to write steps. So the first step is to rewrite. We're going to rewrite the expression as the sum or difference of unit circle angles. Okay, so that's our first step, and I'm gonna say the step and then we're gonna do the step. So we rewrite the expression as the sum or difference of unit circle angles. Now let's just list some. We know that in degrees. So we've got 30 degrees, we've got 45 degrees, we've got 60 degrees. These are our unit circle degrees. Of course, we have 0 degrees. That's not going to be that helpful, but we do. Let's see, 60 degrees, you know, we've got 90 degrees and so on. I mean, we've got more. So what we want to do is think of, and it doesn't matter which numbers you use or whether you do an addition or subtraction. In the end, we're all going to get the same answer. Since 15 is so small, I probably would go with subtraction. And I think I want to do 45 degrees minus 60 degrees. That's what I want to do. So that's my very first step. I'm going to rewrite it as the sum or difference of unit circle values. So secant of 15 degrees is the same thing as secant of 45 degrees minus 30 degrees. Okay, so that's my first step. Now, this extra step is because we don't have addition subtraction for secant, but we do its reciprocal. So we're going to rewrite it using a reciprocal property. And this is just because it's secant. So I'm going to change this to 1 over cosine of 45 degrees minus 30 degrees. Okay, so we've finished step 1. We've got it into, it needs to be cosine, sine, or tangent. Those are our only options. Those are where we have our, you know, addition subtraction properties. Okay, so the second step, what we do next, once we get it rewritten, is we expand with the formula. We're going to expand this with whichever formula goes with it. Okay, so 1 over, let's see, it's cosine. We know cosine's the not so nice one. He's a little fussy. So remember, he has to come first. So it's going to be cosine 45 degrees, cosine 30 degrees. And we're asking cosine to subtract. What's cosine going to do? Add, because cosine's not so nice. Add. So then sine has to come last, because, you know, that's how cosine is. So then it's sine of 45 degrees, sine of 30 degrees. Okay, so I did step 2. I expanded with the formula. The last step that we're going to take is we're going to use unit circle values to evaluate. We want to know what those numbers are. And so this is where the unit circle is not going away. I've talked about that before. We've been working on it for a few months now. I'm hoping you're getting more and more comfortable with the unit circle, because it's going to be with us for a while. All right, so 45 degrees. So 45, 45, 90s. We like those. Those are easy. They're just root 2 over 2. And that's 45 degrees is in the first quadrant, so it's just root 2 over 2. So cosine of 45 degrees is root 2 over 2. 30 degrees, if we want, let's just make a little, so 30 degrees would be low like that. So cosine, that would be longer along the x, so that's going to be a bigger number, so that's the root 3 over 2, plus sine of 45 degrees is root 2 over 2, and sine of 30 degrees, okay, so this is like 30 degrees, so that's when x is longer and y is shorter, so y is going to be the 1/2. Okay, we okay so far? So I used my unit circle values to evaluate, and now it's just arithmetic. Now I just need to fix my arithmetic. So here we go. So root 2 times root 3 is root 6, and 2 times 2 is 4, plus root 2 times 1 is just root 2, and 2 times 2 is 4. Okay, so that's a complex fraction. We need to do our complex fraction fixing thing. So we need to have one fraction in the denominator, so that's root 6 plus root 2 over 4. Now if you recall the keep, change, flip. Keep the numerator, change division to multiplication, flip the denominator, and that will 1 times 4 over root 6 plus root 2 is just 4 over root 6 plus root 2. Now on your homework, it's going to ask you for exact values. That's what it means. It means you need to put the radicals in your answer. Don't try to convert it to a decimal because they don't want that. They want the actual just exact. The exact means we don't approximate with a decimal. It's just the exact answer. All right, so I want to pause there for a second. Are we okay? Okay. So now B, we're going to do the same process. It's a little bit harder with radians because radians are in fractions. And so what I do, because I have to see things, you guys are probably way better than I am, and you could do this without writing them down, but I have to write them down. So pi over 6 is my first unit circle value, and in twelfths, that would be what, 2 pi over 12. Okay, and I'm going to need to either add or subtract to 11 pi over 12, so I need bigger numbers. So let's keep going. Then we've got pi over 3, that would be what, in 12, so that would be 4 pi over 12. Okay, I'm still not big enough. What about pi over 4? Pi over 4 would be what, 3 pi over 12, okay. So far I can get to 7, 3 plus 4 is 7. I need 11, so I need bigger ones. So I'm going to keep going. Let's see, we got pi over 2. That gives me, what, 6 pi over 12. Let's see, I need 11. 6 and 4 is 10, so I can only add 2 numbers. Please don't try to add 3. It's just 2. So let's keep going. We need a little bit bigger. So let's see, 2 pi over 3 would be next. So 2 pi over 3 would be what in 12? So it would be, what, 8 pi over 12. So let's see, 8 and something is 11, right? 8, 9, 10, 11. Okay, so here we go. We found our combo. I'm going to use this one. 8, 9, 10, 11, 8 and 3. 8 and 3 is 11. Now, I don't have to do those. I could keep going if I wanted bigger numbers and do some other kind of combo, but I just want to find the first one and then I want to stop. Okay, is everybody okay with that? You see what I'm doing? I'm just doing this step 1. I'm rewriting the expression as the sum or difference of unit circle values, unit circle angles. And so since we're in fractions, we need to put all our unit circle angles in twelfths so I can figure out what makes 11 pi over 12. Okay? So now we can rewrite it. So this is going to be the same as sine of pi over 4 plus 2 pi over 3. All right, so that's step 1. We rewrote it as the sum or difference of unit circle angles. Okay, great. So step 2, we want to expand it with the formula. Now this is sine. Remember, sine is the nice one. Sine shares. So it's going to be sine of pi over 4, and then sine is going to share. Cosine gets to come in. Cosine of 2 pi over 3. Now we asked sine to add. What's sine going to do? Sine's going to add because sine is the nice one. When we ask sine to add, sine adds. And now they're going to reverse. And now it's going to be sine of the second angle and cosine of the first angle. Okay, so that's our formula. That's our step number 2. We just expanded. Okay, is everybody okay? Okay, so pi over 4, I really kind of like the 45, 45, 90s, don't y'all? The unit circle values are always root 2 over 2, either positive or negative, right? So sine of pi over 4 is root 2 over 2. Now cosine of 2 pi over 3, I'm going to have to do a little unit circle. Let's see, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. 4 pi over 6 is 2 pi over 3, so that's this one right here. All right, so it's bigger along the y, it's taller along the y, so y is going to be bigger. Cosine is x, so that means cosine is going to be a half, but in the second quadrant, is x positive or negative? It's negative, right? In the second quadrant, x is negative, so this is going to be negative 1/2. All right, so then sine of 2 pi, okay, so sine is taller, it's bigger, it's y, it's bigger along the y-axis, so, and sine is positive in the second quadrant, so this is going to be root 3 over 2. And then cosine of pi over 4 is nicely root 2 over 2. Okay, so we just you did step 3. We used the unit circle values to evaluate. Now it's just a matter of arithmetic. So root 2 times negative 1 is negative root 2. 2 times 2 is 4. Root 3 times root 2 is root 6. And 2 times 2 is 4. Now on your homework, they're going to want you to put those together into one fraction. And just to make it prettier, I'm going to put the subtraction one second. I don't think the homework matters, but I'm going to do the square root of 6 minus the square root of 2 over 4. All right, how are we doing? That's one way that we will utilize the addition subtraction properties. Okay? All right, so on the second page, we're going to find other ways to utilize addition and subtraction properties. So let's go to the second page. And on this first one, what we were doing on number 1 is we were using the formulas to expand. We were expanding. Now this, if you look at this, it's already been expanded. We're going to do the reverse. We're actually going to condense it because it says, I mean, it's hardly believable, but it says we can find the exact value. And when it says the exact value, that means unit circle. Somehow we're going to get a unit circle value. That's what, when it says exact, that's a code word for, hey, you're going to be using unit circles. So let's take a look at how it's been expanded and try to decide if this was a sine or cosine expansion. So notice how sine and cosine are together. What does that, which of the trig functions does that sound like? The nice one or the not so nice one? The nice one, because it's sharing. Sine is sharing. So this is a sine expansion formula. This is sine. And it's adding. And since it's adding, what would we have asked sine to do? Add, because sine is nice. So it's sine of 18 degrees plus 27 degrees. That's what would have created that expansion. So we're having to actually think about it in reverse. Okay, is everybody okay with that? All right, so now that we have it in reverse, we're not done. We need to keep going because we're apparently supposed to be able to find the exact value of this. So hopefully when we add 18 and 27, we're going to get a unit circle value. And we actually do. When we add 18 and 27, we get 45 degrees. Okay, and we know it's a 45, 45, 90. We kind of like those. That's root 2 over 2. And that's our answer. Okay, so how are we on the it's already expanded. How are we on condensing an expanded one? Is that okay? We'll be able to figure that out? Okay. All right. Now, number 3 takes into account 2 different angles. And you're going to be faced with some of these 2 different angles. And these are in quadrant 1. These angles are in quadrant 1. And so if we look at tangent of A is 2/3, well, that's not a unit circle value, right? But we actually want tangent. And tangent is just uses tangent, right? So I can actually leave this alone. I don't have to do anything to that whatsoever. I can just leave that alone. Now, I don't need sine of B, I need tangent of B. So first of all, let's look. If this would be like, this is like triangle, this is triangle A. And if I needed to make the triangle, I would, to find tangent of A, but I already have tangent of A, so I don't need to make the triangle. This one is going to be triangle, these are 2 different triangles. This is triangle B. Now this triangle I do have to make because I don't know what tangent of angle B is. So now I'm going to pause here for a second. Is everybody okay with me not making triangle A? Does everyone understand why I am not making triangle A? I'm not making triangle A because I already have the information I want from angle A. I already have what I want. Okay, maybe it'll become more clear once we do the formula. But I do need to make triangle B. And we're in the first quadrant. Okay, so here's my triangle B. This is angle B. And sine is opposite over hypotenuse. Now this should feel a little bit familiar to us. Do we remember working with triangles in previous lessons? Remember that? This should feel comfortable and like we've done this before, because we have. So now I want to use Pythagorean to find out what that other side is. Let's see, so it's what, 5 squared plus b squared equals square root of 41 squared. So b squared would be 41 minus 25. So b squared is 16. Since this is on the positive x-axis, this is going to be a positive 4. All right, so tangent of angle B is opposite over adjacent. All right, so this is what I need from that triangle. I need tangent. So let's see, why am I so set on tangent? That's because this is what I'm trying to find. Tangent of A plus B. So let's do that. Let's do that formula. So I'm just going to write the formula out if you remember. It's tangent A plus tangent B over 1, and what's the sign going to be? It's going to be opposite, right? Minus tangent A times tangent B. That's why I didn't need to make triangle A, is because I already had tangent A. I didn't need any other values from the triangle. Does that make sense now, why we didn't have to do it? If it hadn't given us tangent of angle A, let's say it gave us cosine of angle A, we would have had to make the triangle just like we did triangle B. We would have had to do that. But they already gave us what we wanted. No sense in making a triangle if we don't have to. So now let's replace. We're going to substitute. In place of tangent A, we're going to put 2/3. In place of tangent B, we're going to put 5/4 over 1 minus. Again, in place of tangent A, we're going to put 2/3. And in place of tangent B, we're going to put 5/4. Okay, now we've utilized our formula, and it's just a matter of arithmetic now. We just need to clean it up. So that's a like big complex fraction, which is not okay. So I need common denominators in the numerator. So let's go to 12. So that would be what, 8/12 plus 15/12 over 1 minus. Let's see, 2 times 5 is 10, and 3 times 4 is 12. Okay, so we're making progress. We're not done yet, but we're getting closer. All right, so let's go here. So 8 and 15 is what, 23, so that's 23/12 over, let's see, 1 would be like 12/12. 12/12 minus 10/12 would be 2/12. Okay, making good progress. Remember, fixing our complex fraction, keep, change, flip, keep the numerator, change division to multiplication, flip the denominator, and that's going to give us, when we simplify it, it's going to give us 23/2. And if you need to write that step, the keep, change, flip step, please do. Please do. All right, so that's how we're going to utilize these formulas with different angles, if we had 2 different angles. Okay, and if they're not unit circle values, what do? Triangle. We do a triangle, just like we did previously in previous lessons. If they're not unit circle values, we do a triangle and make sure we're in the correct quadrant. Okay, so next I'm going to show you how you might see this in a proof. I don't know if I said, did y'all get the practice proofs that I sent out to you? Okay, good. So I sent out to you the practice proofs, the key to and it's just practice. It's not for a grade, but it would be helpful if you practice. The key is in the content library. If you want to check your progress on the practice proofs, you can certainly do that with the key. All right, so now let's do this proof. We want to, let's see, let's work on the left side. That looks way more complicated. And this would be a sign subtraction property. Let's remember sign subtraction. So sign is the nice one. Remember, sine shares. So sine of x, cosine of pi over 2. Sine is being asked to subtract, so what's sine going to do? Subtract. And then they're going to change places, so then it's going to be sine of pi over 2 cosine of x equals right-hand side, and this would be, this is the subtraction property. Subtraction property. Okay. All right, next we've got some unit circle values that we can use, so let's do that. So sine of x, let's see, cosine of pi over 2 is 0. Sine of pi over 2 is 1. Okay, and that would be, the reason would be unit circle. All right, so we're making our way. So we did a subtraction property to expand it. Then we evaluated the pieces we could. Okay, does anyone see where we're going? What are we going to do next? We're just going to go ahead and multiply everything out, right? So we end up with negative cosine is the right-hand side, which is true, and that I just multiplied. So that's an example of how you would do a proof, or how a proof might be utilized with a sum or subtraction property. Okay, how we doing? Okay. We have two more to do, and these are, I want to point out to you, these are very, very similar. So let's highlight these. This is very, very similar to this. Okay, they're almost identical. 5 is easier because it deals with specific values. 6 is more difficult because it wants us to write things in containing u and v. Remember that problems we did the other day with u and v? Remember that? Like y'all's favorite one, right? You're like, no. And we had a problem on the test that was like a bonus with that. Remember that? Yes? Okay. So this one, number 6, we're going to learn how to do, but just like the other U and V one, we're not going to test you over it. If you see it, it might be a bonus or something, but it's important that you see how these are related. It's important you see how they're related. So let's kind of dig in here and let's look at what this is, what this represents. Let's just kind of take a peek at this piece right here. This is an angle. I'm going to call this is angle, I'm just going to put it in words right now. This is angle, and I'm just going to call it angle A. That's what that is. The inverse cosine of 1/2 is an angle measure. And this, I'm going to call this angle B, because that represents an angle. And when we get to number 6, I'm going to do the same thing. I'm going to do the same thing. I'm going to name them so that it's easier for us to work with. Easier for us to work with. Okay, so what this is going to turn into, the reason I'm doing this is because this is going to turn into sine of A plus B. Okay, that's why I named those angles A and B, so that I could get my sine of A plus B. Okay. What we're going to do is we're going to, let's put some steps on here. So number 1, we want to identify angle A and angle B. That's what we want to identify angle A and angle B. Okay? That's an and angle B. So I've identified them. We actually need to find out what they are. We need to figure out what they are. So identify angle A and B. Part of identifying it is, and we can just add that in, identify angle B and find the values. We need to know more than just that's angle A and angle B. So let's work on that for just a moment. Let's get step 1 done. So angle A, let's think about this. Inverse cosine of 1/2. This is a principal value. Is 1/2 a normal unit circle value? Yes. So this is a unit circle angle. Inverse cosine or arc cosine of 1/2 is a principal value, and when it's positive, which quadrant are we in? We're in the first quadrant, quadrant 1. When, I'm just going to remind you, when this number is positive, when the 1/2 is positive, we're in quadrant 1. Okay, so I need a quadrant 1 angle where cosine is 1/2. So let's remind ourselves, so cosine is x, so we want the x to be smaller than the y, so we're looking at this angle measure, 1 pi over 6, 2 pi over 6. So that's 2 pi over 6. So what we're going to say is angle A is 2 pi over 6, which is pi over 3. So that's what we would do if it was a unit circle value. This is, we've identified what angle A is. Okay, are we okay so far? Okay, so now we're going to identify what angle B is. Is 3/5 a unit circle value? No, so what are we going to have to do? A triangle. That's what we do. When it's not a unit circle value, we draw a triangle. So let's draw a triangle. It's going to be in the first quadrant because 3/5 is positive. So this is angle B. Sine is opposite over hypotenuse. And so that is a 3, 4, 5 right triangle. And so this represents angle B. This is angle B. Okay, so step 1, we identified angle A and angle B, and we actually identified them. We got some information about them. We're not just saying, oh, that's angle B, that's angle A. We know stuff about them. All right, so now step 2 is where we expand. We're going to expand our formula. So sine A plus B, it's sine, so sine is really nice. So it's sine A cosine B. Sine, we're asking sine to add, so what's sine going to do? It's going to add because it's very nice. And then sine is going to take the second angle, B, and then cosine is going to take the first angle. Okay, so we expanded. And then the last step is to put our unit circle slash triangle. I don't want to leave poor little triangle out. It'll hurt his feelings. So unit circle or triangle values to evaluate. So we're going to pull the values off of angle A and angle B. That's what we're going to do. And these are our steps to do a problem like this. Okay? So we need to read sine off of angle A. So we need to think, what is sine of pi over 3? So that's a unit circle value. Sine of pi over 3, that's when y is bigger. That would be root 3 over 2. Okay. Cosine of B, so we need to look at the triangle. We need to read cosine off of the triangle. Let's see, cosine is adjacent over hypotenuse, so cosine would be 4/5 plus. Is everybody okay? Okay. Sine of angle B, so let's read sine off of the B, off the triangle. Let's see, sine is opposite over hypotenuse. And cosine A, let's see, angle A is is pi over 3. Let's see, pi over 3, and that's where it's taller on the y, so x is going to be smaller, so x is going to be 1/2. All right, so we used our unit circle values. Now it's just arithmetic. So we've got 4 root 3 over 2 times 5 is 10, plus 3 times 1 is 3, 5 times 2 is 10. Now, you're probably going to get one like this on your homework, and they're going to want you to put it in one fraction instead of two. So we're going to rewrite this to be 4 root 3 plus 3 over 10. Okay, how are we doing?
Can you explain how you found cosine of angle A?
Sure. So what I did is I've identified where angle A is. Here's angle A. It's this pi over 3. And I need to think to myself, what would x be? And we can go back to our unit circle values. So let me write our unit circle values up here. This would be like 1/2 root 3 over 2. Those would be our unit circle values. And that would be my x, and that would be my y. Right, the x is smaller and the y is bigger. So that means that cosine of, or sine of pi over 3 would be root 3 over 2 because it maps to the y. Is that okay?
Yes.
Okay. Any other questions on number 5 before we go to crazy number 6? Crazy number 6. Okay. I think I only put one homework problem like number 6. You're welcome. I'm just joking around. I'm sure you like to do a lot of them. Probably not. I know. I'm just teasing. Okay, so here we go. So we're going to now, let's remind ourselves what we did over here. Remember how we set up this one to be angle A. This one is angle A. Remember that? And we set up this one. We're doing the same thing. We set up this one to be angle B. Okay, same thing. Angle A, angle B. And what I'm going to do is, so let's remind ourselves about the relationship between an inverse and its normal function. Remember how the x's and the y's trade places? Remember that? So what causes this to be a little bit crazier is that I actually need to solve for u and I need to solve for v because I'm supposed to put everything in terms of u and v. That's what I'm supposed to do. Okay, that's what I'm supposed to do. Okay, so let's do this first one. So that means that if inverse sine of u is angle A, then sine of A would be u. Okay, so let's put this in. So I'm doing this inverse with this one, right? If inverse sine of u is angle A, then sine of A is u. Okay, we'll do the same thing over here. If inverse cosine of v is angle B, then cosine of B is v. Okay, I just switched the x's and the y's with the so sine is regular old sine, inverse sine is the inverse of sine. I just took them and switched their x's and y's. Okay, are we okay so far? Okay, so you're like, why'd you do that? Okay, so we're going to get to why I did that. So we're going, these are our pieces of information that we need. So now what we're going to do is we're going to do what we did over here. So this is the same thing as sine of A plus B, right? Just like we did on the other one on number 5. I told you they were very similar. Okay, so we're going to expand it. So it's sine, so it expands very nicely. So sine of A cosine of B plus sine of B cosine of A. Okay. Are we okay so far? So what I want to do is highlight this for you. See how this is sine of A and this is sine of A? See that? I'm going to replace sine of A with a U. And see how this is cosine of B and this is cosine of B? I'm going to replace cosine of B with a V. Okay, are we okay so far? Now where it gets a little wonky is we don't have sine of B and cosine of A, so we're going to have to do a little bit of work for those. And that's where I'm going to come over here. So kind of go with me. Just kind of say, sure, Dr. Wright, we're right with you. Let me fix this cosine of B so we can see it. Okay. All right, so what I'm going to do is I'm going to set up two different Pythagorean identities. I'm going to say sine squared A plus cosine squared A is 1. Would you agree with me on that? Right, that's just a regular Pythagorean identity. And then I'm going to do another one with B, sine squared B plus cosine squared B is 1. Okay, and it will become apparent to you in just a moment why I'm doing that. Okay. So, what do I need? I need sine of B, and I'm going to get sine of B from here. I need sine of B, and I'm going to get it from there. Okay? I need cosine of A, and I'm going to get cosine of A from here. That's where I'm going to get them from. Okay, it's going to take a little bit of algebra to get them, but that's where we're getting them from. So I'm going to pause here for just a second. This is why I have to do these Pythagorean identities, is because of the sine B cosine A. All right, so what we're going to do in the first one is we're going to solve for cosine. So cosine squared A equals 1 minus sine squared A. So to get cosine to the single power, we would have to square root both sides. So cosine is simply square root of 1 minus sine squared A. Okay. Let's do the same thing on the other Pythagorean identity. So I've got sine squared B equals 1 minus cosine squared B. I want plain old sine. I don't want sine squared. So I'm going to square root both sides, and I'm going to get sine of B is square root of 1 minus cosine squared of B. Okay, I'm really, really close. So I want you to notice what sine of A is. I'm circling it right here. Sine of A is U. Here's sine of A right here. I'm going to change cosine of A. It's going to be the square root of 1 minus U squared. I just took the sine of A and replaced it with a U like we did previously. Okay, so now let's look at cosine. So cosine of B is V. Okay, cosine of B is V. So I'm going to replace cosine of B with V. Okay, I'm going to pause there for just a moment. So now I'm simply going to replace sine of B with this sine of B thing, which is square root of 1 minus V squared. And I'm going to replace cosine A with the cosine A thing, which is square root of 1 minus U squared. And this is my answer. Everything is in terms of U and V. All right.